describe the reflections that carry a regular polygon onto itself. In other words, we'll be looking for lines of symmetry. Throughout this video, keep in mind that we will only be considering regular polygons. In geometry, the word regular is actually a pretty important word. It tells us that the shapes have congruent sides and congruent angles. The simplest regular polygon is an equilateral triangle. An equilateral triangle has 3 lines of symmetry, one for each vertex. We notice that each line of symmetry connects a vertex with the midpoint of the opposite side. That same method works with regular pentagons also. Since there are 5 vertices, there are 5 lines of symmetry. However, when we try to connect the vertices of a square to the opposite side, we don't get lines of symmetry. Instead, we need to connect the midpoints of opposite sides. Additionally, the diagonals are lines of symmetry. These 2 types of lines of symmetry can also be found in hexagons. We can connect the midpoints of opposite sides and draw the diagonals. So with the equilateral triangle and the pentagon, we are connecting the vertices with the midpoints of opposite sides to make lines of reflection. In the square and the regular hexagon, we are connecting the midpoints of opposite sides and drawing the diagonals to get these lines of symmetry. Let's see how these 2 different situations affect the number of lines of symmetry that these regular polygons have. The equilateral triangle had 1, 2, 3 lines of symmetry. The square had 1, 2, 3, 4 lines of symmetry. The regular pentagon had 1, 2, 3, 4, 5 lines of symmetry. And the regular hexagon had 1, 2, 3, 4, 5, 6 lines of symmetry. To generalize that idea, if a regular polygon has n sides, then it has n lines of symmetry. So if we were asked how many lines of symmetry a regular triacontagon has, that's a polygon with 30 sides, or we could call it a 30gon. From what we have seen here, we can conclude that a regular 30gon has 30 lines of symmetry. And signing off.